Hello everyone, welcome to the channel. Here we have question number 2 given in page number 101 for chapter 5. I am up and down, round and round. So let us see this question. Question is an isosceles triangle ABC. So we have triangle ABC, which is an isosceles triangle, means uh, if I consider triangle ABC like this, and it is an isosceles triangle, means two sides are equal. Let us see this side as AB and AC. In an isosceles triangle, uh, I find that the two sides of a triangle are equal. Inscribed in a circle means this triangle is present inside a circle. So if I want to draw a circle outside this, so it can be drawn in this way. So that is, this triangle ABC is inscribed in a circle with AB is equal to AC. AB and AC sides are equal, so that I have already shown. Show that the altitude from A to BC, we have to draw a altitude from A to BC, passes through the center of circle. It passes through the center of circle that we need to show. So I can just write down to show that AD is altitude. Here the point D I have considered on BC. AD is altitude and it passes through center of circle, that we need to show. So now that we need to have some construction in this question, so let us write down what constructions to be followed. So join OA I have already joined, and extend it to meet to BC at point D, that we have done. Join OL, O and L perpendicular to AB. Join OM perpendicular to AC. So this construction I will show. OL is perpendicular to AB, we have to draw this one, and OM is perpendicular to AC, that we have to draw. So this is the general construction we need to draw for completing the question. Now let's solve this question further. So here we can see that OL is perpendicular to AB. OL is perpendicular to AB, so it will be a perpendicular bisector. So it implies that AL is equal to LB, and now I can write down this, that AL is half times of AB. Similarly, we have drawn OM is perpendicular to AC, so it will be a perpendicular bisector. It means AM is equal to MC, so I can just write down AM is half times of AC. Now uh, we have this as equation 1 and this as equation 2. We know that already in the question that AB and AC both are equal. So half times of AB and half times of AC will also be equal. If I compare from 1 and 2, from 1 and 2 reference, and taking the reference of given part, I can say that AL is equal to AM. So we have got this one, AL is equal to AM. Now AL is equal to AM. So here the angle ALO and AMO, the angle ALO is equal to AMO. Why it is there? Because it is 90 degree each, that we can write down, and OA is equal to OA. Here the common side of both the triangles. So with this reference I can say that the triangle ALO is concurrent to triangle AMO. So we have gone through that how to prove the concurrency of these two smaller triangles inside it. So with this reference now I can say by CPCT. Here I'm making as angle 1, this is angle 1 and this is angle 2. So by CPCT I can say that the angle 1 is equal to angle 2. This is what are corresponding parts of concurrent triangle used to be there from these concurrent triangles. And which concurrency rule I have applied, it is one angle and two sides, one ALO. So this is side angle side. Now after this we will see that so angle 1 and angle 2 are equal to each other. Now let's move to next. We have triangle ABD and triangle ADC. So we have AB is equal to AC, that is because it is given as isosceles triangle, and angle 1 and angle 2 is also equal, that we have just proved above. And AD is equal to AD, which is common for both the triangles. So here by triangle ABD is congruent to triangle ADC by SAS concurrency rule. Now by CPCT I can say that angle ADB is equal to angle ADC. So that is by CPCT, congruent part of congruent angles. If both angles are equal, so it will be 180 degree. So I can write down here that angle ADB plus angle ADC is equal to 180 degree. As both the angles are equal, so both angles, it will be equal means 2 times of angle ADB is equal to 180 degree. So angle ADB is equal to 90 degree. So another angle will also be a 90 degree. So I can say that AD is perpendicular to BC. So AD is an altitude which is there passing through angle A, and it is a perpendicular bisector for BC. So this altitude is passing through center O. So this is how we have to solve this question.